Okay, so the first question is draw the cell cycle. So the cell cycle is going to be the G1 phase, S phase, G2, and N phase. So in the cell cycle, by the end of the cell cycle, we're going to have like, the cell is going to have 2 daughter cells, right? So there's 3 checkpoints. There's going to be checkpoint in G1, checkpoint in G2, and in the middle here, there's going to be checkpoint and mitosis. So what's going to happen is in G1, before we get to the S phase, what's basically the question is going to be, is the cell, is the environment, does the environment have the appropriate growth factors, and is it like a good place to replicate, basically? So, and then in S phase, it's going to be synthesis of DNA replication. And then in G2, after the DNA replication, in S phase, the question is going to be, are the DNA replicated? And if it is replicated, is it replicated properly? And then after this checkpoint, we're going to pass to M phase. In M phase, the checkpoint is going to be in metaphase. Before we get to anaphase, the question is going to be, are the chromosomes lined up? And if they're lined up, then in anaphase we split them, basically. So the second question, we already explained the checkpoints. The third question is going to be the role of CDK inhibitors. Before I explain that, I'm going to explain what CDK is. So CDK is a cyclin-dependent kinase. Basically, what it does is, if the questions and the checkpoints are satisfied, it's going to push the cell forward to the next phase. But so CDK inhibitor, what it does is, if there's a damage in the cell, for example, what's going to happen is it's going to stop it from going to the next phase, or if the checkpoints are not satisfied. So P53 is going to be the transcription factor that binds to the promoter in P21, and P21 is the CDK inhibitors. So I'm going to draw a cyclin here and CDK here. So for the CDK to be activated, we need the cyclin in the first place. So this is activated and it's pushing it forward. Something happens, the cell is damaged, right? So in this case, then what's going to happen is the P53 is going to bind to the promoter in P21, and P21 is going to be activated. So when P21 is activated, it's going to act as an inhibitor, and then the CDK can no longer work at the moment. So because of this, the cell is not going to be able to pass this checkpoint from G1 to S. But if the fifth question is, what if there's a damaged cell but the P53 is mutated? If the P53 is mutated, then it will be unable to bind to the promoter in P21. So it doesn't, if it doesn't bind to the promoter in P21, then P21 won't be activated. So there will be no P21 to stop the cell cycle from moving forward. So even though there's a damaged cell, the cell cycle is going to still move forward. So what is this going to cause? This is going to cause, possibly, like, because the cell is going to keep replicating when it is damaged, it's going to cause cancer, possibly. That's it. Thank you.